Hi everyone, and welcome again to Nettle, the go-to place to learn about business, finance, economics, and much, much more. Please don't forget to subscribe to our channel and click that bell notification button below so that you never miss fresh videos and tutorials you might be interested in. Many thanks to our current Patreon supporters and YouTube members for making this video possible, and we'd also greatly appreciate if you consider supporting us as well. So please check the link in the description or click the join button below for more details. My name is Seva, and today we are going for something a little bit different. We'll use the power of statistics to investigate one of the most common stylized facts in association football on an example of the Premier League since its inception in the 92-93 season. Namely, we will investigate whether the well-known phenomenon of the second season syndrome exists using statistics and some simple hypothesis testing from Econometrics. The second season syndrome is a notion that if a newly promoted side to the Premier League survives their first season, their performance in their second season in the league is much worse. It is sometimes so substantially worse that the teams get relegated in their second season in the Premier League. And one of the most informative examples recently has been Sheffield United, that were promoted at the start of the 2019-20 season, and they were quite successful, reaching 9th place in their first season in the Premier League, amassing a total of 54 points over 38 games, which is a very good result for a newly promoted side. However, in the second season in the Premier League, in the 2020-21 season, the last season, they were relegated rock bottom of the Premier League with only 23 points. However, does this regularity persist on average? Is there really a statistically rigorous second season syndrome? You might be tempted to say, of course, because we see something like that in the current 21-22 Premier League season with Leeds United, who finished 9th in the 2021 season, amassing 59 points, even more than Sheffield United. They're also struggling, and they are in a relegation battle right now with 6 games to go at the time of recording. But statisticians and econometricians have their own say in dealing with these types of stories. We would like to assemble a representative data set of all teams who had their second season in the Premier League since the start of records, measure their performance using some objective criteria, and then figure out whether the difference in their performance in the second season and in the first season is statistically significant. We have got here a data set of all Premier League seasons since its breakaway from the league, from the 1992-93 season until the most recent full season completed, 2021. So we have got 586 data points here. Please note that for the first several seasons of the league, there were 22 teams in comparison to 20 teams that contest the league right now. So there were more games played, and that means that to measure performance, we'll need to adjust various performance characteristics like the number of wins, the number of points, or the number of goals scored, or the goal difference, by the differing numbers of games. Keeping that in mind, the most obvious criterion to measure performance of our teams and figure out whether the second season syndrome exists would be to calculate the points per game ratio, and that's a very common heuristic used in football analytics. To do that, here we have got a table with all unique teams that have appeared in the Premier League. There are 49 unique teams that contested the league since its beginning, as well as all of the 29 seasons we've got the data for. And here we can use the sum-ifs function to very neatly calculate the points per game ratio for each of the teams in each of the years, provided it appeared in the league. So here we can use the sum-ifs function and refer the total amount of points here, this particular column, column J from the original row data sheet, and we need to lock it both row and column wise, as this column would not change no matter what cell we refer to. And then we need to carefully think about the criteria we care about. First of all, we care about picking the right team out of the 49 teams we are investigating. So we're referring to the criteria range of all team names, and we're referring to the team name in the column A from the target sheet, points per game sheet here. And we'll lock the column because as we drag it across, we don't want the team name to change. Then we also need to calculate the sum of points in the relevant season, in the relevant year. That means that we have to refer to the year column over here, column A from the raw data sheet, and then we need to refer to the correct year number from the target points per game spreadsheet. So here we refer to the B1 cell and we are locking the row here. So if we see what this formula gives us, it gives us the total amount of points that Arsenal scored in the 1993 season. And indeed we see that Arsenal finished 10th, amassing 56 points in total. But we also want to know how many points per game did they manage to gain, which means that we have to divide that by the sum-ifs function, but instead of points, column J, here we would have to refer to the games column, which is column D. And that is something that will preserve no matter what characteristic, what indicator are we interested in. Another problem that we might encounter is that if we drag it down, we'll see divided by 0 errors appearing in case a particular team has not been in the Premier League at a particular season. So for example, Barnsley and Birmingham City, they were not Premier League teams in the 1992-93 season, so here we have a divided by 0 error. So to avoid that, we need to input the if error function, and if there is an error, if we know that this team is not in the Premier League, we'll input an A for data not available. And keeping that in mind, we can enforce this formula throughout the whole sample and get a very nice and tidy representation of relative success of different teams if they have been in the Premier League. Also, what is useful here is that we can use the record, namely whether the team is in the Premier League for a consecutive number of seasons, to determine whether we can take a particular team into consideration for our second season syndrome statistics calculations. For example, Barnsley were promoted into the Premier League for the 1997-98 season. However, they did not stay there for the second season running, so this particular calculation is of no use for our test of interest. However, here we can already see some notable second season syndrome candidate observations, namely for Rovers and for Bolton in 2001-2002 season and 2002-2003 season. So we can compare these figures to determine whether the ones in the second season are considerably lower, as well as this particular observation for Bradford City, comparing their performance in the 2000-2001 season and 99-2000 seasons. How to automate that so that we don't have to manually look at those indicators throughout this large table? Well, we can code a variable that would take 1 if this observation is relevant for our second season syndrome calculations, and 0 otherwise. First of all, the 1993 observations are irrelevant by definition, as that's the very first season of the Premier League. We're not considering that. For the 1994 observations, we need to manually keep in mind that only one team survived the 1992-93 season from the newly promoted ones, and that was Ipswich Town. So we can just manually put a 1 here alongside Ipswich Town for 1994. And from that point on, from 1995, we have got 2 observations from the points per game spreadsheet that would allow us to automate the calculation of whether we put a 0 or a 1 here. So for the 1995, for Arsenal, for example, what we need to do is we need to look if in our points per game spreadsheet, the 1993, so 2 years lag behind variable is equal to an A, then we are potentially interested in this team as it has not been in the league in 1993, and if it has been promoted in 94 and survived 1995, this is our hero. This is something that we can take for our calculations. So then we have to check that if the points per game D2 is equal to an A, then 0, it means that this team either hasn't been around at all throughout the period or has just appeared for one meek 1994 season. And if it is true that if B2 is an A and if D2 is not an A, we need to finally check if C2 is an A. Because if it is an A, then the team has been just promoted in the 1995 season, so we are not content with that, so 0, and 1 otherwise. That finally concludes our calculations, and we can close the appropriate number of parentheses and enforce the formula. And that would work all the way across. So then, if we look at the total table, we'll see that there are 46 non-zero observations in total. There are 46 second season observations we can consider for our calculations. Let's break them down by season. Let's sum how many we have got in 1994, and so on until the very end, until the most recent season available. And we can see that sometimes all 3 newly promoted teams survive, and we can use them for our calculations. Sometimes only 1 or 2 out of the 3 newly promoted teams survive. And sometimes, namely in 1999, all 3 newly promoted teams go down, and we have got no statistics, no data to retrieve from there. What it means for our estimation strategy, for our empirical test design, is that we have to calculate differences in performance across the seasons and then map them into these zeros and ones we have calculated in the second season spreadsheet to retrieve our test statistics. So here we can use the if-error function and refer to the difference in performance, here points per game ratio, and if it's an error, then we can just refer to an A indicator, enforcing it throughout all seasons, as well as throughout all of our 49 teams. And here we can start calculating the second season effect, as well as testing for its statistical significance. We can figure out what is the average difference in terms of points per game ratio in the second season compared to the first season. We have to only take into account relevant observations, so it means that the second season variable should be equal to 1. And then we have to refer to the table with points per game differences. And so that we can flexibly adjust this to different performance indicators, not only points per game. Let's remove this points per game sheet reference, as we are on this spreadsheet that will work regardless. So we can see that on average, the newly promoted side, if it survives the first season, scores 0.07 fewer points per game in their second season in the league. Over the course of the full season, that corresponds to a loss of 2.5 points, which can be quite substantial in terms of determining its survival or relegation. However, is this statistically significant? Is this large enough, given the volatility, given the unpredictability potentially of the league and of the performance of the teams? Is it large enough to warrant us to think it's not random? To figure this out, we have to calculate the standard error of our estimator, which means that we first have to figure out how many observations we've got. We already know it's 46, but it's always good to check, and it's indeed 46. And then we can calculate the standard error using the sample standard deviation function, and here use the if function as well, saying that we only will take observations if the second season variable is equal to 1. If it's the case, we'll calculate the standard deviations of performance differences, here points per game differences, and nothing otherwise. That would give us the standard error of 0.36 points. However, to adjust it for our sample size, we can divide it by the square root of the count here, giving us the standard error of 0.0537 points per game. A t-statistic is the number of standard deviations we are away from 0, meaning that we divide this difference, average difference, by the standard error and get a t-stat of minus 1.34. And then we can apply a two-tailed t-distribution, a two-tailed t-test, referring to the absolute value of the t-stat, as well as the number of the degrees of freedom, which would be the number of observations minus 2, as we impose the mean and the standard error, reducing the number of degrees of freedom by 2. That gives us a p-value of 18.63%, meaning that there is an 18.63% chance that such a realization could occur randomly, without any meaningful difference in performance between the first and the second season of the newly promoted sides. This is larger than 10%, meaning that we cannot deem this result statistically significant at any conventional confidence threshold, meaning that the second season syndrome, if we measure it by the points per game basis, does not exist. However, what if we measure the second season syndrome based on goals scored or the win rate? Well, our design allows us to very easily change our specification to reflect that. Let's copy this sheet and create a copy of that we'll call, let's say, goals for per game. Here we can quite easily check what we need to change in our formulas. So instead of the points that we refer to here, column J, we can refer to the column H from the raw data spreadsheet, which is goals for, goals scored by the team over the course of the season. So if we change it to H and apply it throughout, all of our calculations would be automatically adjusted. And here we see that while the effect for goals for per game is a little bit more significant, it still doesn't breach the 10% confidence threshold. And over the course of the season, newly promoted sides, if they survive the first season, score 2 less goals over the course of the 36-game season, which is, can be deemed substantial or economically significant, but alas, it's not statistically significant given our estimation design. And finally, let's test our strategy using the win rate. To do that, we can simply copy this spreadsheet and rename it as win rate. And for win rate, we can change our goals for column into the wins over the course of the season column, which, if I recall correctly, is column E in the raw data sheet. So here we change our H column into the E column, enforce it throughout, and we'll see that, again, there is a negative effect, which means that teams perform worse in the second season, but it's not statistically significant. And on average, it's less than a full win over the course of the season. However, even if we had a statistically significant result here, there is an econometric intuition that would perhaps prevent us from concluding that the second season syndrome is true and indeed exists. Because there are two important concepts that are at play here in terms of our sample selection design, which are the regression to the mean concept and the sample selection bias concept. Consider this. To get our team included into our sample, it needs to survive one season in the league. And why does it survive the first season in the league in comparison to some of its peers that go down? Well, in 2004, 2 teams survived and 1 team went down from the previously promoted 3. Well, these 2 teams could have been genuinely better in their first season. However, they could have just been lucky. And in the second season, this luck can just dissipate. This random shock to their performance could simply wane. And that means that the second season syndrome statistic that we get from any of our estimations could be random disturbance in disguise. Secondly, and this is quite a common concept that is quoted by football professionals, is that some of the benefit of newly promoted sides, such as Sheffield United or Leeds United in the past 2 seasons, were the unpredictability of their tactics and their playing style. And in the second season, when those tactics are figured out, the other teams have a much easier time facing these teams in the league. And that could also contribute to the inflation of the second season effect figures in those particular tests. Nevertheless, rigorous statistics tells us that the second season syndrome is not large enough to be considered statistically significant, and it means that for all intents and purposes, if we use the rigorous language of econometrics, it doesn't exist. And that's all there is for testing for the second season syndrome in the Premier League using statistics and econometrics. Please leave a like on this video if you found it helpful. In the comments below, I'm eager to see any feedback and any suggestions for other real-life applications of statistics and econometrics. And please don't forget to subscribe to our channel and consider supporting us on Patreon. Thank you very much, and stay tuned.